In this video, we're going to do a few examples where we're solving and graphing compound inequalities. So, the difference between this video and last video is that instead of just having a single inequality, now we have compound inequalities. So let's go ahead and get started with the first one. So we'll notice that, it says there's this main difference, which is that it's this inequality or this inequality. So that means x must satisfy this inequality or x can satisfy this inequality. Either way, x is the solution, okay? So if x satisfies this one or it satisfies this one, then that is a possible solution for x. Okay, so let's go ahead and get started by, first I'm going to add 5 to both sides, okay, to get 5 by itself here. So I'll have negative 8x is greater than 16. Then I'm going to divide both sides by negative 8. Now, I'm going to remember that since I divided it by a negative number, I'm going to flip the inequality. So instead of being less than, now it's going to, or instead of 8x over negative 8x is greater than 16, now it's going to be 8 is less than negative 2. Okay, so I flipped the inequality. Alright, let's do the same thing to the other side. Let's go ahead and get x by itself. So first thing I'm going to do is distribute this 5. So I'll have 6x plus 11 is greater than 5x plus 15. Okay, and let's get like terms together. So let's subtract 5x from both sides. Okay, and I'll have 1x here plus 11 is greater than 15. So I'm going to subtract 11 from both sides, and I get x is greater than 4. Okay? Alright, so when I'm graphing this, so, you know, x is less than negative 2 or x is greater than 4. Okay? So if I'm going to graph this, I would say, okay, so I'm going to do a number line here. And here's 0, 1, 2, 3, 4, 1, 2, 3, 4. So 3, 4, or I do that. 2, 1, negative 2, negative 3, negative 4. Okay, so at negative 2, I have an open circle, right, because I'm strictly less than. So, and then x can be less than. Okay, so that's a possibility, is that x can be less than negative 2. Another possibility is that x is greater than negative 4. So all these answers that are greater than negative 4 are also valid. Okay, so the way you would write this in interval notation, you would say, okay, so I go from negative infinity to negative 2. I don't include negative 2, so I have the soft bracket. And I would say that unison, so this is the unison sign, okay, with 4 to infinity. Okay. So let's do another example. This one's slightly different. Instead of saying or, it says and here in the center. And so what does that mean? It means that x must satisfy this inequality and it must satisfy this inequality. So both of these must be satisfied. Okay? So when it was or, it's just one or the other had to be satisfied. Now they both have to be satisfied in order for x to be in the solution set. Alright, so let's go ahead and get started. First thing I'm going to do is distribute this 3 in. So I'll have 3x plus 3 minus 2 is greater than or equal to 4. Then I'm going to go ahead and, let's see, combine like terms. So 3 minus 2 is 1. Okay, I'm going to subtract 1 from both sides. 3x is greater than or equal to 3. Divide both sides by 3. X is greater than or equal to 1. Oops. Greater than or equal to 1. 3 divided by 3 is 1. Okay, so now moving on to the next inequality. So first thing I'm going to do is distribute this 3. So I have 3 minus 3x plus 13 is greater than 4. Then I'm going to combine like terms. So I have this negative 3x. But then I have 3 plus 13, which is 16. It's greater than or equal to 4. I'm going to subtract 16 from both sides of the equation. So I'm left with negative 3x is greater than, so 4 minus 16 is negative 12. I'm going to divide both sides by negative 3. And I get x. Now, since I divided by a negative number, the inequality flips. So I get x is less than okay? X is less than 4, right? Negative 12 divided by negative 3 is 4. All right, so now X must be greater than or equal to 1 and less than 4, okay? So I'm going to draw this out. Here's 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, so I have a closed circle at 1, right? Because I'm I'm greater than or equal to 1. So I have a closed circle at 1, and then from the 1, I'm allowed to be more than 1, okay? And then in addition to being, so I have to be greater than or equal to 1, and then I also need to be less than or equal to 4. So here's 4, and 4 has an open circle because it's not less than or equal to, it's strictly less than, so that's why it has the open circle. And then I have to be less than that, okay? So now if I were to be greater than and less than, what I end up with is this area between 1 and 4. Okay, so my solution in interval notation, you would say I would have a closed bracket at 1, right, because of the equality that's there. I can equal 1. So I have a closed bracket at 1, and then I go all the way to 4, and then I have a soft bracket, or soft parentheses. So it means that I get infinitely close to 4, but I never reach it. Okay, one last question. So let's go ahead and get started with this one. The only thing that is slightly different about this one is usually we're used to seeing inequalities that only have 2 sides. This one has 3 sides, so we just need to be a little extra careful about that. Okay, so first thing I'm going to do is distribute my 3. Okay, so I'm going to distribute the 3 in here. So I'm going to rewrite everything. So negative 5 is less than 7x is less than, so negative 3 times 5 is 15. Okay, and then negative 3 times negative x would be plus 3x. Okay, and that is less than or equal to 5. So now I'm going to combine these two, 7x and 3x. So that would be 10x minus 15 is less than or equal to 5. Okay, so now since there's 3 parts or 3 sides to this inequality, we have this side, the middle, and the right. I'm ready. I'm going to subtract, or I want to add 15 to all those sides, right? So usually I only have to add 15 to the right and left side. Since there's 3, basically there's 3 sides to this equation. You need to be careful that you do it to all 3 parts. Okay, so negative 5 plus 15 is 10. And then we're left with 10x in the center because these cancel. And then 5 plus 15 is 20. Okay. Last step is divide everything by 10. Okay. Divide all the sides by 10. So this 10 cancels, right? 10 divided by 10 is 1, left with x in the center, and then we're left with 2 on this side. 20 divided by 10 is 2. So, oops, I forgot the inequality. So when you're reading this, you say, okay, so x is more than 1, okay? X is more than 1, and then x is less than or equal to negative 2. Okay, so both of those things, so it's kind of like an and. X must be less than 1, and x must be greater than 1, sorry, and x must be less than or equal to 2. So now when I'm drawing this out, here's 0, 1, 2, negative 1, negative 2. Okay, at 1, I have an open circle, okay, because it's just strictly greater than. X must be strictly greater than. So I'm greater than means I'm going in this direction, right? And then at 2, I have a closed circle, or closed dot. And then x must be less than 2, so I'm going in this direction. Alright, so then the graph would be in between those two, because both of those must be satisfied. It must be greater than 1 and less than or equal to 2. So when I'm drawing this out, my interval notation, my solution, would be 1 to 2, and then I'll have a closed bracket at 2.